Welcome to NCX Maths, and today in this video we are going to prove this theorem. Any intersection of closed sets in R is closed in R. And for the proof we consider F to be an arbitrary collection of closed sets in R, and we are going to prove that its intersection is also closed in R. That means it's arbitrary intersection, that is uh, suppose uh, the intersection B, intersection A belongs to F A, and this is the arbitrary collection of closed sets in F, closed sets in R, which are the member of the set F, and we're going to show that this arbitrary intersection is also closed in R. So suppose we let this to be T, and we're going to prove that this arbitrary intersection, that is T, is a closed set. So we're going to show this, that T is also a closed set. And to prove that T is a closed set, we are going to start with T complement, as by the definition of a closed set, if its complement is open, then we say the set is a closed set. So we're going to start with T complement, and we're going to prove that this T complement is open, which will eventually prove that T is a closed set. So for this T complement, we have intersection of A belongs to F, is A, and we are going to find out its complement, and here we can apply De Morgan's law. So by De Morgan's law, this arbitrary intersection of A, this can be written as the union of A belongs to F of each A complement. This is by using De Morgan's law. So here now this is converted as the arbitrary union of A complement, and here, since each A is a closed set, so we have this A complement is an open set. So now this is the any union of open set, arbitrary, that is arbitrary union of open set, and we have already proved the theorem that the arbitrary union of open set in R is open in R. So we can say that this whole union is also an open set. And finally, this proves that this T complement is open in R. Open in R. So we can say that T is closed in R. So this is by the definition of a closed set. Since its complement is open, so we can say that the set is closed in R, and in this way we have proved that any intersection of closed sets in R is closed in R. So that's all for today. So I hope you found this video useful, and if so, please like the video, subscribe to the channel, and turn on notification for more higher mathematics related videos. Thanks for watching. Have a nice time.